substitution rule, or also called u-substitution, it's for finding the antiderivative, is analogous to the chain rule for taking the derivative. This is helpful in integrating a composite, or finding the antiderivative of a composite function. Typically, we replace the inner function with u and then express du in terms of dx. The substitution rule is going to greatly expand our ability to find antiderivatives. Okay, so this example here, find the definite integral or antiderivative of 2x over square root of 3 plus x squared. So in the denominator, we have a composite function. We have 3 plus x squared under the square root. So u typically is the inside function, so we're going to let u equal 3 plus x squared, and then du, take the derivative of u, we get 2x dx. Okay, so we can rewrite this as replace the 2x dx in the numerator with du, and square root of 3 plus x squared in the denominator, square root of u. And we can write this as antiderivative of u to the negative 1/2 du, and use the power rule. When I add 1 to the exponent and divide by the new exponent, it's the reverse of the power rule for the derivative. For the derivative, you take 1 away from the exponent. Here we want to add 1 to the exponent. So this is going to be negative 1/2 plus 1 is 1/2, so it's u to the 1/2, and divide by the new exponent, so it'll be divided by 1/2, and then plus a constant. Derivative of constant is 0, so there's not just one antiderivative, this plus any constant. It will also be an antiderivative for the same function. So we can flip the half in the bottom and change it to multiplication. 2 times u to the 1/2 plus a constant, and so this is 2 square root of u plus a constant, and then put the x's back in. So it's 2 square root 3 plus x squared plus a constant. Okay, so that's the first example. That's u-substitution for finding derivatives of composite functions. Here's another example. This is a definite integral. So the integral from 0 to pi over 4 sine squared x cosine x dx. We can do this a couple of different ways. The sine squared x is shorthand for sine of x quantity squared. So I'll rewrite this as integral from 0 to pi over 4 sine x quantity squared cosine x dx. And we can one way of doing this is just to take the antiderivative of the integrand here. So let's write this as for step 1. Just do it without the make it an indefinite integral. Okay, make this a indefinite integral, and then so u is going to be the inside function. U is going to be sine x, and then du will be cosine x dx. So this, we can rewrite this as the integral of u squared du, and use the power rule again. Add 1 to the exponent, divide by the new exponent. So u to the third plus a constant, and then we can put the x's back in. This is u is sine of x, so this is sine of x to third over 3 plus a constant. Or we can write this as 1/3 sine cubed x plus a constant. Okay, so that's the step 1, and then step 2. Now, so step 1 is to just find an antiderivative, and then step 2 we can rewrite the definite integral now as we can write this as 1/3 sine cubed x. And for the definite integral, we don't need the plus a constant. Any antiderivative will produce the same result, and we want to evaluate this at 0 and pi over 4. Okay, so this will be 1/3 sine cubed pi over 4 minus 1/3 sine cubed of 0. Sine of 0 is 0, so the last term is going to be 0. Sine of pi over 4 is root 2 over 2, so this is 1/3 root 2 over 2 cubed. So this is 1/3 root 2 over 2, root 2 over 2, root 2 over 2. And root 2 times root 2 is 2, so we'll cancel 2 on the bottom. We'll cancel 2 of these root 2's. And then we can multiply the denominators. We have 1/2 times 1/2 times 1/3. It's going to be 1/6, 1/12 rather. 1/12 times the square root of 2. Okay, so that's the. And then the other way of doing this is to, another way of doing it is to change the limits of integration. So this one, we first found the antiderivative, and then use that to evaluate the definite integral. We could also change the limits of integration. So again, our function is what we want is the integral of from 0 to pi over 4 sine x squared cosine x dx. Again, we'll let u be the inside function, sine x, and du is cosine x dx. But we can also change the limits of integration here. If x is equal to 0, u is the sine of 0, which is going to be 0. If x is pi over 4, u is going to be the sine of pi over 4, which is root 2 over 2. So as x goes from 0 to pi over 4, u is going to go from 0 to root 2 over 2. So we can just, when we make the substitution to u, we can change the limits of integration. Root 2 over 2 u squared du. And then take the antiderivative as u third over 3 from 0 to root 2 over 2. And replace u by root 2 over 2. Is 1/3 root 2 over 2 to third, 1/3 root 2 over 2, root 2 over 2, root 2 over 2. Root 2 times root 2 is 2, so the 2 on the bottom, one of the 2's on the bottom will cancel 2 of the root 2's, and denominator 2 times 2 is 4, times 3 is 12, so it's 1/12 root 2. Okay, so you can do it either by changing the limits of integration or finding the antiderivative first and expressing it in terms of x, and then put in the original limits of integration. Okay, so sometimes it's useful to do a reverse substitution. So here's an example where we'll have to do a reverse substitution. Again, we have a composite function, usually u is going to be whatever inside the inside function. So u is equal to 2x plus 3, and that means du is going to be 2 dx. So that takes care of the dx and the 2x plus 3 to the 10, but we have an extra factor here of x. So it's going to be helpful to solve for x, to know what to put in for x here. So if we subtract 3 from both sides, we get u minus 3 is equal to 2x, and then divide by 2. That gives us x is equal to u minus 3 over 2. or it's equal 1/2 u minus 3. And then dx, that also means that dx is going to be 1/2 du. So let's then make the substitution here. So this original integral, we have u to the 10th, and then x, we replace x by 1/2 times the quantity u minus 3, and then we have dx we want to replace by 1/2 du. Okay, so so it's 1/2 times 1/2 is 1/4. So it's 1/4, and we can distribute the u to the 10th. U to the 10th times u is u to the 11th, and it'll have u to the 10th times -3 is minus 3 u to the 10th du, and then we'll use the power rule. Add 1 to the exponent, divide by the new exponent. So this is going to be 1/4 u to the 12th over 12 minus 3 u to the 11th over 11 plus a constant. And if we distribute the 1/4, this will give us u to the 12th over 48 minus 3 u to the 11th over 44 plus a constant. And then we can put the x's back in. So this is 2x plus 3 to the 12th over 48 minus 3 times 2x plus 3, I'm running out of room, to 11th, 2x plus 3 to 11th over 44 plus a constant. So I'll read it right down there. I was kind of running out of room there. So this is going to be, the final answer is 2x plus 3 to 12th over 48 minus 3 times the quantity 2x plus 3 to 11th over 44 plus a constant. Okay, and I put some, I have some additional exercises. I won't go through them all, but if you want some extra examples, you can go to the course files in Canvas. I have these additional examples, and I put in some of the answers here, about half of the answers. So if you want some additional practice, you can go to Canvas, and of course also on the WebAssign there'll be you can get some additional practice in WebAssign in the homework. Okay, so that concludes this presentation.